Hello everyone, myself Dr. Sujata, Department of Information Technology, Vignan's Foundation for Science, Technology and Research. In our today's session, we are going to discuss about exception handling in Java. Now here what we are going to discuss in exception handling are what are the basic concepts of exception handling, what are the types of exceptions, what about the built-in exceptions, and what are the various keywords that are available in Java to handle those exceptions and how to use those keywords. So those things that we are going to explain in this today's session. So next one, first coming to the basic concepts of exception handling, first we need to know what is the difference between error and exception, and also what is the importance of handling the exceptions. Those things first we need to know. Now, coming to the error, what is an error? What is an error? An error indicates a serious problem that a reasonable application should not try to catch. So, it is a serious application that a reasonable serious problem that a reasonable application should not try to catch. That is, we cannot handle the error. So, if error occurs, the application will not be executed, it stops the execution, we cannot get the output. It is a serious problem which cannot be handled. And coming to the exception, exception indicates a condition that a reasonable application might try to catch. So here an exception can be handled. If it is an exception, it can be handled, we can continue the execution of the program. But error, it should be corrected, not handled. Error cannot be handled. If we have not corrected the error, we cannot execute the program. But if we have an exception, we can execute the program by handling the exception, right? So this is the main difference between error and exception. Now coming to an exception, how we can give a technical definition for the exception. An exception is an abnormal event that rises during the execution of a program and that disturbs the normal flow of execution of instructions. And also we can say that an exception is a runtime error. An exception is a runtime error. So here what is an exception? An exception is an abnormal event that rises during the execution of a program and disturbs the normal flow of execution. Here I will show you one example how we can handle the exception and what are the advantages of handling those exceptions. Now here see a scenario where 10 statements are there in my program. So here my program execution starts from statement 1. Sequentially the statements are executed. After 1, 2 statement will be executed. After 2, 3 statement will be executed. And here you can see that an exception occurs at the statement 5. Now whenever an exception occurred at the statement 5, if this exception is not handled, the execution of program will stop there. The rest of the statements, that is from 6 to 10, cannot be executed by the program or by the system. So if we handle the exception at this statement, if the exception is handled, we can execute these statements also. That is, initially if an exception is occurred, it stops the normal flow of execution. If I want to continue for the normal flow of execution, we need to handle that exception. Now, handling of exception provides the execution of a complete program, and it easy to identify the program errors and error handlings, and we can propagate the errors and we can meaningfully report the errors whatever present in my program, and we can identify easily the types of errors. All these things can be possible by doing exception handling. These are the advantages of exception handling. Now let us see a small program, another program. So here I have a class hello, and in this class I have a main method, and here you can see I have taken two variables. First variable is a, whose which is assigned a value 10 and another variable is b, and here I have not assigned any value for that b. Now I want to do an operation a divides 0, that is I want to divide a with 0. The result I want to assign to the variable b. Now here I have written a print statement, whatever the value I am getting into b, that value I want to print. But here you can observe that when I go for compiling this program, it doesn't show any errors. The program is perfectly written. Wherever we used the syntaxes, class names or main methods or declarations or print statements, wherever we have written everything perfectly, so this program compiles perfectly. So there are no any compile time errors in this program. But if I try to run this program, we cannot get the output. It shows some error. Which type of error it shows? This type of error it shows. What is that error? Let us see. Java.lang.arithmetic exception. What is that arithmetic exception? Divide by 0. So we cannot divide any number with 0. We will get an infinite value. If we divide with 0, we will get an infinite value. That cannot be done here. So here at this statement we got an exception. Since we have not handled this exception, here this statement or the rest of the statements which are present in my program cannot be executed, right. So this shows a simple arithmetic exception. Now here you can see what is the superclass of exception, what are the different types of exceptions that we have in our Java programming. So mainly the first superclass of exception is a throwable class. So all the exceptions are subclasses of that throwable class, that superclass. Now here the throwable class, we can represent both errors and exceptions in that throwable class. Now errors means they are asynchronous, whereas exceptions means they are synchronous. Now here there are two types of exceptions that we have. One are the runtime exceptions and other one are IO exceptions, input output exceptions. Now whatever the example we seen in our previous example is a runtime exception. We didn't get any error at the compile time. So the program is executed in a very good manner, when compiled in a very good manner in compilation time, but it is showing an error when we try to execute the program. So that's why such error is to be called as runtime exception, right. So see, so what are the different types of exceptions that we have, categories of exceptions. See here, java.lang is the package wherever the superclass is present, the exception superclass is present. Throwable is the superclass. Next, exception is also a superclass. For this exception class we have various subclasses such as arithmetic exception, null pointer exception, number format exception, class not found exception, IO exception, SQL exception, like that, where there are different array index out of bounds exceptions and string index out of bounds exceptions. Like that, we have different types of exceptions in our program. We may encounter in our program. So all these types of exceptions can be properly handled, and we can continue for the normal flow of execution. And coming to the errors, virtual machine error, out of memory error and stack overflow error. So but those errors cannot be handled, we need to correct the errors. Errors cannot be handled, exceptions can be handled. So these are the different types of exceptions that what we have. And see here, what are the major keywords that are available in Java for handling exceptions? So from beginning onwards we are saying that exceptions can be handled, errors cannot be handled. Error should be corrected in the program, but exceptions can be handled. How we can handle the exceptions in our Java? So what is the facility that is provided for us to handle the exceptions? So here our Java provides 5 keywords for handling the exceptions. What are those 5 keywords? Let us see. The first one is try, second one is catch, third one is throw, and next one is, fourth one is throws, and finally last one is finally. These 5 are the keywords that are available in Java for handling the exceptions. What are those? Try, catch, throw, throws, finally. Now what are the syntaxes of using these keywords? Now let us see the syntaxes. Try, so we will write the keyword try, whatever the code we want to monitor for error or for exception, that block of code can be written within the flower process. Below that try, whatever the code that I want to monitor, whether there is exception or not, I want to monitor a part of the code, that block of the code can be written within the braces. And immediately after try, we need to write a catch block. We need to write a catch block. Now we are assuming that here an arithmetic exception may occur in my program. So I am thinking that an exception may occur, that the type of exception is also an arithmetic exception may occur in my program. Now here I want to handle that exception. For handling that exception, here I need to write which type of exception that you want to caught, whether it is an arithmetic exception or it is array index out of bounds exception, or it is other type of exception, whichever the exception you are expecting. So for catching that exception, you need to write the name of that particular exception class, right? And here this represents the object of that particular exception class, right? This is the name of the exception class and this represents the object of that particular exception class. And whatever the statements that you want to print in the catch block, you can write those statements here, whatever the statements that you want to report. So if you catch the exception, whatever the statement that you want to print on the screen, those statements can be written here. Now here we can write multiple catch statements. So like that, here I have written one catch statement and here I have written another catch statement which represents another exceptional class with its object name, and here whatever the block of statements that I want to print on the screen, when I handle the exception by using this particular catch block, I can write those statements here, and so on. Like that, so many levels of catch statements can be written. And finally here this is a keyword, finally is a keyword which is used to execute even an exception occurred and it is not handled. Whatever the part of the code that I want to execute surely, whether exception is occurred or not, even if the exception is occurred, we are unable to handle that exception, even that in that case also, if I want to execute a particular block of code, that block of code should be written in the finally. So whether you handle the exception or you have not handled the exception, this block of code will be executed. Right, throw and throws can be defined later. So these two are the particular keywords which are used to throw an exception or from a method if you want to throw an exception. So these two keywords particularly used. So generally for exception handling we will use these three keywords: try, catch and finally. Now here we can see some methods which are used to print the exception information. Basically we have three methods for printing the exception information. Now here you can see the first method, print stack trace is the first method. Now what this method prints? This method prints the total information of the exception. What is the package and what is the class of the exception and which type of exception is that, in which program that exception is occurred and in which line of that program the exception is occurred. For printing the entire information of exception, we use print stack trace. Here you can see that this method prints exception information in the format of name of exception, description of exception, stack trace. Stack trace means what is the file name, in that file in which line that particular exception occurred. All these things can be printed by using this print stack trace method. Now here you can see an example program. Here I have taken a class GFG which contains a main method. Now here I have written a variable A whose value is 5 and I have another variable B whose value is 0, which is assigned with 0. Now here I want to perform A by B, that is I want to perform a division operation between A and B, right. So now I have a doubt that there may be some exception occurs, right. That's why in the division operation there is a chance of occurrence of exception. That's why I want to monitor that code. Whatever the code I want to monitor, that should be written within the try block. that should be written within the try block. Now here I want to monitor this code. So here I have performed the operation, division operation between A and B. So here there is a chance of occurrence of exception. That's why for monitoring whether exception occurring or not, for monitoring I have written that statement in the try block. Now if the exception is occurred, that should be handled. So for handling that exception, here I have written immediately after try block I have written catch block. Here I am expecting that there may be a chance of occurrence of arithmetic exception. That's why I have used the class name arithmetic exception, and for this class I have created an object E. For this class I have created an object E. Now here I am using the method print stack trace to print the information of that particular exception. So this method will be present in the exception superclass that can be accessed by any subclasses of that particular exception superclass. Here arithmetic exception is the subclass of the exception class. So it can access this print stack trace method. So here I am accessing this method by using the object name E dot print stack trace. Now here you can see that my program execution starts from the main method. First A will be assigned a value 5 in the memory and B will be assigned a value 0. Now I want to perform an operation 5 by 0. Since it is not possible divide by 0 error occurs, here an exception is raised. Whatever the exception raised here, that is thrown to the catch block. It checks for the relevant class, whether the catch block contains a relevant class or not for handling that exception. Yes, obviously this is an arithmetic exception. Here the relevant class is found. This class catch block handles that exception by using that arithmetic exception class. Now here this catch block contains a print stack trace method which prints the information of that particular method, that particular exception, right. Now here whatever the output we are getting, java.lang.arithmetic exception, and what is that exception? This is the name of the exception, divide by 0, that is the name of the exception. And in which file that exception is present? In the file gfg.main. In the file gfg.main that exception is occurred, and in that file at which line that exception is occurred? Java 10th line, at the line 10 the exception is occurred. So for printing the entire information we can use the method print stack trace. Now coming to the next method, toString method. So toString method, how toString method is used to print the information of exception. Now here you can see this method prints exception information in the format of name of the exception, description of the exception. It doesn't give any information of the file and line numbers of the program. So in which file that particular exception occurred and in which line that particular exception occurred, that information will not be given by the toString method. So here you can see that Java, I have written a class gfg1, and here a is equal to 5 and b is equal to 0. Same operation I want to perform. Here I know that I am going to divide 5 with 0. Here an exception may occur. That exception particularly is an arithmetic exception. So here I have written arithmetic exception. Now here I want to print the exception information. For printing that exception information I have written a statement e.toString method is accessed, and that statement, whatever that e.toString method can get, that information I want to print. That's why I have written within the print statement. Now here you can see this is the output of this program, java.lang.arithmetic exception, so which gives the name of the exception and divide by 0, which gives the description of the exception. Here it doesn't mention the file name or line number, all these things. One more method is there for printing the exception information. That method is getMessage method. GetMessage method. This method prints only the description of the exception. It doesn't prints the name of the exception, or it doesn't prints the file name, or it doesn't prints the line number also. It just prints the description of the exception. Here you can see the example. The same example I have taken. Now it is handling. Here I used the e.getMessage method. This becomes the output of the program. So just it prints divide by 0, which is the description of exception. So here the name of the exception is arithmetic exception, that will not be printed here. Right. So these three are the main methods which are used to print the descriptions of the exceptions occurred in our program. So the three methods are, first one print stack trace method, second one toString method, and third one get message method. Next, coming to the types of exceptions, we have mainly two types of exceptions, user defined exceptions and built-in exceptions. So now from the names itself it is clear that the Java in itself it is having some built-in exceptions to handle, which can be handled by the Java program itself, and user defined exceptions. Some exceptions can be explicitly defined by the users. Such type of exceptions are to be called as user defined exceptions. Now coming to the built-in exceptions, we have two types of exceptions, two types of built-in exceptions. First one are the checked exceptions and another one are the unchecked exceptions. Now coming to the checked exceptions, so class not found exception, interrupted exception, IO exception, instantaneous exception and SQL exception, all these are the checked exceptions. That is, here these exceptions, no need of handling these exceptions can be checked, and after that we need to correct. If that particular class is not available in our program, we need to write the class name properly if that class is not available. Like that, all these exceptions can be checked. Right. At the time of compilation it will not show any error. So at the time of execution of the program it shows the errors. Now unchecked exceptions, these cannot be checked. Right, unchecked exceptions, these should be handled. Now those exceptions are arithmetic exception, class cast exception, null pointer, array index out of bounds exception, string index out of bounds exception, array store exception, illegal thread state exception. So all these are the different exceptions which are unchecked exceptions. Now let us see, I am going to explain more about these built-in exceptions. Now see here, built-in exceptions that are already available in Java libraries. So we already seen some such exceptions such as array index out of bounds exception, string index out of bounds exception, arithmetic exception, or all these are the available exception classes in a Java library, right? So such exceptions are to be called as built-in exceptions. These exceptions are able to define the error situation so that we can understand the reason of getting this error. So all these defines the error situation, and it can be categorized into two broads. One is checked exceptions and another one are unchecked exceptions. Now coming to checked exceptions are to be called as compile time exceptions because these exceptions are checked at the compile time by the compiler itself. So the examples for checked exceptions are class not found, interrupted, IO, instantiation, and file not found, etc. All these are the checked exceptions. These can be identified at the time of compilation, right? And coming to the unchecked exceptions, the unchecked exceptions are just opposite to the checked exceptions, and these cannot be identified at the time of compilation. These can be identified at the time of running the program. Now here you can see the examples for unchecked exceptions are arithmetic exception, null pointer exception, array index out of bounds exception, etc. Right. Now user defined exceptions, I already said you that the exceptions which are not already available in the Java libraries, those exceptions which are explicitly created by the users, such type of exceptions are to be called as user defined exceptions. These user defined exceptions can also be handled by the users. These also can be handled. Now, so here how we can use the keywords try, catch, throw, throws. Finally, already we seen some examples with try, catch. Now we are going to see all the keywords try, catch, throw, throws, and finally how these keywords can be used to handle the exceptions properly in our programming. Now we already know that try block is used to monitor a block of the code where the possibility of occurrence of exception is present, right? So for monitoring that block of code we can use the try what is that keyword. Now catch block, coming to the catch block, it is used to process the exception. Whatever the exception occurred in the try block, that can be thrown to the catch block for processing that exception, for handling that exception. We use this catch block. Now immediately after try block, we need to write the catch block. We should not write any statement between this try block and catch block. So after immediately try block closing, we need to start the catch block, right? The syntax for using catch block is catch. Here I need to write the type of exception that we are expecting, that name should be, class name should be written, and here we need to write the object name. Whatever the messages that I want to print within this catch block, those messages can be written here in the catch block. And I already said you that the finally block, which should be the last statement of the program. Whenever you want to do the exception handling, the finally block should be written at the end of the program. Okay, we cannot write finally before try, or finally between try and catch, or immediately after catch. So like that we cannot write finally block. Finally block should be the end of the program, and the finally block executes whatever the code which is present in that block, even an exception is occurred or not occurred. Even that exception, if it is occurred, even it is not handled also, the block which is present, the block of code which is present in the finally can be executed, right? Now, I already said you that no statements are placed between try block and catch block, and finally should be the last statement, last block of the program. Now we will see the example programs. Now how can we use that try and catch? Now here you can see that I have written a class using try catch is the name of the class. This class itself contains a main method. Now here I have written a try block which contains two variables a and b, and here I want to divide that 10 with 0. So here I want to print that b value. So whenever my control comes to execute this statement, it finds that an exception is occurred. From here the exception will be thrown to the catch block. This statement cannot be executed. This statement cannot be executed. So first this statement will be executed, then the control goes to here to execute. Here exception occurred, that exception will be thrown to the catch block. Here the suitable exceptional class is present. This suitable exceptional class handles the exception, and whatever the statements which are present here, those statements can be printed immediately. Since the exception is handled, the rest of the statements, whatever the statements which are present in my program, all those statements can be executed. Suppose for example, here if I have written the exceptional class as like this, array index out of bounds exception. Suppose if I have write like this, what happens? Now here the occurred exception is arithmetic exception. The occurred exception is arithmetic exception. Whatever the exception occurred here, that will be thrown to the catch block. But here the class I have written in the catch block is array index out of bounds exception, which cannot handle the arithmetic exception. So here the exception is not handled. So the rest of the statements, this statement and this statement cannot be executed. So if we write a suitable class, corresponding class, whatever the exception occurred here, if we write the corresponding class in the catch block, then only the exception can be handled and the rest of the code can be executed, right? Now what becomes the output of the program? So here, since I have written the suitable class, the exception is handled and these statements can be executed, and whenever these statements are executed, it prints the statements exception raised as well as quit. These two statements can be printed there. Now I am going to show how to use finally. So in addition to try catch, how to use finally also I am going to show. Now here you can see that using try catch finally is my class name which contains a main method. Here I have taken an array, x is an array. Now how to declare an array? So int x is equal to new int of 10, that is I want to store 10 elements in that particular array. Now I am going to write a statement within the try block. I am expecting that some error may occur, some exception may occur in the next lines of my code, so that I want to monitor that code. So whatever the code I want to monitor, that code I have written in the try block. Now I want to assign a value 100 to x of 20. Actually, what is the size of my x? My x size is 10 only. So that is my array can store only 10 elements. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 to 9, my array can store 10 elements only. But what I am trying here, I want to assign a value 100 to the index 20. Is that index is available in my x array? No, that index is not available, right? So an exception is occurred here. Whatever the exception occurred here, that exception thrown to the catch block. If the suitable class is there for handling that exception can be handled. Here I have array index out of bounds exception class, the same class I have written. I have expected the same type of exception may occur, so I have written the same class. This exception can be handled by this class and it prints the statement exception caught. Right. After that I have written finally. So I cannot write this finally block at the beginning of the program, or between try and catch also I cannot write. It is not possible to write finally block at any place of the program. Only the possibility provided for writing the finally block is end of the program. Now even here the exception occurred, even the exception is not handled, whatever the code which is present in finally block will be executed. Here the exception is handled and the code which is present in finally can be executed. Now suppose for example, here I have written the class exception class name as arithmetic exception. Here I have written the class name as arithmetic exception. Now what is the exception occurred here? Here the exception occurred is array index out of bounds. Here my index is existing up to 9 only, but I want to access an index 20. It is out of bounds, right? Array index out of bounds exception is occurred here, but I have written a class arithmetic exception. Can the arithmetic exception class handle this type of exception? No. Here the exception is not handled. So since the exception is not handled, this statement cannot be executed and the control goes to next. Further, if any statements are there, those also cannot be executed, and whatever the statements which are present in finally, those statements will be executed even the exception is not handled. So in this case, what becomes the output of my program? Not possible to print. This statement is present in my finally block, and also another one more statement is there in my finally block which is nothing but quit. So whatever is the case, exception occurred or not occurred, exception handled and not handled, whatever it is the case, the statements which are present in finally block will be executed definitely, right. So these two are the best examples that can be shown for usage of try, catch and finally, right. So I hope that everybody understand what about how to use try block, catch block and finally block in exception handling. Now I want to explain how to write multiple catch statements. How to write multiple catch statements. That is, till now whenever I have written a program, so I have used such type of statements, b is equal to a by 0, which is nothing but an arithmetic exception. Now another one more statement is I want to access a of 20, that is, for example, if I want to print the element a of 20 where the size of my array is 10 only. The size of my array is 10 only. So here I am getting an exception, array index out of bounds exception. Here I am getting an exception, out of bounds exception. So now if I have taken a lengthy code, in that lengthy code there may be a possibility of more number of different types of exceptions. Suppose the same program may contain one arithmetic exception, one array index out of bounds exception, and one string out of bounds exception, like that. Different exceptions may be present in the same program. Now if I write only one catch block, I can handle only one type of exception. But how to handle the remaining exceptions occurred in the program? For handling different type of exceptions which are occurred in the same program, we can write multiple catch blocks. We can write multiple catch statements. And how to write those multiple catch statements? I already said you that immediately after try block we need to start the catch block. So no more statement can be written between this try block and catch block. Immediately after first catch block, I need to write the second catch block, and I need to write the third catch block, and so on. Like that I need to write. Now no more statements can be written between two catch blocks also, and any of these catch blocks cannot be written before the try block. First I need to write the try block, then only I can write the catch block. What is the purpose of catch? Handling the exception. If the exception is occurred or not, without getting that information, how can I write the catch block prior to the try block? So try block identifies, monitors the code and identifies if any error occurs. That error can be thrown to the catch block, so that we need to write after try, we need to write catch block. So immediately after catch we need to write another catch. Immediately after this catch I need to write another catch. If I want to write multiple catch statements, no more statements can be written between try and catch and between catch and catch also. Right. Now after the completion of all the catch statements, whatever the statements I want to write, I can write all those statements. After the completion of all those statements, finally block should be written. Now immediately after catch block I cannot write finally, right. So this is the representation how we use the multiple catch statements. Now you can see an example program for multiple catch statements. So here I have taken a class name multi-catch, now which contains a main method. So now here I have written a try block. Within this try block I have written some code. Now here you can see that int a is equal to args dot length. Whatever the args here I have passed, the length of that can be assigned to the variable a. So whatever the command line arguments that I am giving, suppose for example, if I am giving the command line arguments like this, the length of this becomes 3 elements can be stored there in the arguments, string args. So the length of that args dot length becomes 3. That value will be assigned to a. Now here I want to print a value. Now I want to divide 42 with a. Whatever the result I am getting, that result is passed to b. And here I have initialized an array C with a value 1. And I want to assign a value 99 to the array at index 42. Actually the size of my array is only one element, the length of my array is 1, but I want to access the index 42. Right. Now here you can observe that if I have not given any command line arguments, the length becomes 0. If I try to divide 42 with 0, here there is a chance of getting arithmetic exception. There is a chance of getting arithmetic exception. Suppose if I give the element, here the value becomes some value. If I give the elements as 10, 20, the value becomes 2. In that case there is no exception. Exception will not come. Right. So if I have not give any command line arguments, here the a value becomes 0. In that case there is a chance of occurrence of arithmetic exception. And here also we know that the size of array is 1 only, but I want to access the 42nd element. I want to place 99 at the place of 42nd index, but the size is 1 only, which represents out of bounds. Here there is a possibility of occurrence of array index out of bounds exception. So, here I am getting two types of exceptions within the same code, right, within the same program. Now, I want to handle those exceptions. For handling those exceptions, here I want to write multiple catch statements. So, here this catch can handle the exception which occurred here, arithmetic exception, and here array index out of bounds exception, this can be thrown to this catch statements. So, first it checks, so whenever an exception occurred here, first it thrown to this catch block. The suitable class is not found. If another catch block is available, the control again throws to this catch block. Here the suitable exception class is available. This can be handled. The exception can be handled, and whatever the statements that we have in the catch block, those can be printed, and rest of the program will also be executed if we handle the exception properly. Right. Now, here you can see, since arithmetic exception is coming, here arithmetic exception class is there, it can handle. So, it prints divide by 0, prints divide by 0. Now, in the same way, so here it also prints array index out of bounds exception. Right. So, this is the way of using multiple catch statements. And not only multiple catch statements, we can use nesting of try statements also. That is, one try block can be written within another try block. So, how to write those things, that I am going to explain. Now, here a try block is placed inside the block of another try block is termed as nested try blocks. So, if any error occurred in the outer try block, it goes to the corresponding outer catch block. Whatever the outer catch block we have written, in the outer try, if any exception occurs, that can be thrown to the outer catch block. Whatever the exception occurred in the inner try, that can be thrown to the inner catch block. Right. Now, here if not corresponding inner catch block is available, that also can be thrown to the outer catch block. Right. Now, you can see an example program for nested try. Now, here I have taken a class n try1 which contains a main method, and here I have written a try block. So, now this try block takes a is equal to args of length and b is equal to 42 by a, and I want to print the value of a. I want to print the value of a, and within this try block, here the try block opened here and closed here. Within this try block, I have written another try block. Within this try block, I have written another try block. See here, if a is equal to 1, a is equal to a by a minus a. If a is equal to 2, int c is equal to 1, c of 42 is equal to 99. So, here in this case, here one exception occurs, here another exception occurs, here also there is a chance of occurrence of an exception. Now, after closing this try block, here I have written a catch block. Here I have written a catch block, index out of bounds exception, and I have written another catch block with arithmetic exception. And so, whenever an exception is occurred here, first it will be thrown to the outer catch block. Here the corresponding class is not present, so again it will be thrown to the next catch block. Here the corresponding class is present, here it can be handled. Here it can be handled. Now, again coming to here also, some exception is occurred here. The type of exception is arithmetic exception. It can be thrown to the outer catch block. Now, here the suitable class is not found there. Again it will be thrown to the next catch block. Here the suitable class is found. Here the second exception will also be handled. Now, here I will get an exception of array index out of bounds exception. This can be thrown to the first outer catch block. Here the suitable class found. Here itself the exception can be handled. Like that, we can write nesting of try statements. So, within a try, I can write here itself a catch block. So, here I can write, so here my try block opened here. Within this try block, I have written try catch. For this try, I can write a catch statement here, and more number of catch statements if I want, I can write. Multiple catch statements can also be written for a single try. but without writing a try, I cannot write a catch block. Without writing catch, I cannot write a try block also. Right. So, together we have to write. First we have to write the try block, then we have to write the catch block. So, this represents the nesting of try statements. So, I hope that everybody understand up to this. So, till now we have explained what is error, what is exception, what are the advantages of handling the exceptions, and also what are the different types of exceptions that we have. Now, what are the various keywords that are available in Java to handle those exceptions, such as try, catch, finally. So, now how to use multiple catch statements, how to do nesting of try statements, and what are the constraints that can be followed to use that try, catch, and finally. All these things that we explained. In the coming session, we are going to see throw, throws, and user defined exceptions. Thank you for listening.